This question is question number 1. This is NEET previous year question. This question is based on Cauchy-Lewis approach, chemical bonding. According to this question, in phosphate ion, the formal charge of each oxygen, formal charge of each oxygen in PO4 triple minus phosphate ion is equal to what? Question number first. And question number second is PO bond order, bond order BO of PO bond in phosphate ion is equal to what? This is question, and according to given options, one by one we will calculate correct answer. The first, we can draw a structure of phosphate. This is structure of phosphate, and now we will discuss about resonance structure of phosphate. 4 resonating structure we can observe. 4 resonance structure. Okay. Again, double bond is here, and again double bond is here. So 4 type of, these are the 4 resonance structure, and resonance structure occurs due to delocalization of pi bonds and pi bond electrons. Suppose double bond is here, double bond is here, double bond is here, and double bond is here. So total number of resonance structure is 4, and total number of PO bond is 1 2 3 4 5. So PO bond is 5, resonance structure is 4. Okay. Now one by one, first we will calculate formal charge. In this formula, formal charge of each oxygen, here -1, -1, -1 and 0. Okay. So average formal charge, here formal charge of each oxygen, here formal charge of O, or average formal charge, average formal charge of O atom in phosphate ion is equal to, the formula is total formal charge, total formal charge divided by total number of O atoms in phosphate ion. Now total formal charge is -3, okay, -1, -1 and -1 is -3, and total number of oxygen atom in PO4 4. Okay. After calculation we can get -0.75. okay, -0.75. okay. So -0.75 first answer. After that we can calculate again PO bond order. So average bond order of PO in phosphate ion is equal to total number of PO bonds in phosphate ion and divided by total number of O atoms in phosphate ion. Okay. Now PO bond is 5, and total number of oxygen atom in phosphate ion is 4. So 1.25. Second answer is. Now final answer is minus 0.75 and 1.25 respectively. This is formal charge of each oxygen and this is PO bond order or average PO bond order. So according to given data, option A is correct. This question is question number 2. According to this question, among LiCl, BeCl2, BCl3 and CCl4, the covalent character follows the order. In these options, which order of covalent character of these molecules are correct? According to given data, initially we will discuss about a structure of LiCl, BeCl2, BCl3 and CCl4. Number of covalent bond is maximum. It means 4 in CCl4, 3 in BCl3, 2 in BCl2 and 1 in LiCl. And atomic size, order of atomic size, lithium, order of atomic size, lithium, beryllium, boron, carbon. These are the all are in same period. So in same period, left to right atomic number increase and atomic size decrease. So maximum covalent character here, atomic size order carbon, boron, beryllium and lithium. So this is the order of atomic size of these central atoms. Now due to maximum number of covalent bond and minimum size of central atom, maximum covalent character shown by CCl4. The order is CCl4, BCl3, BCl2 and LiCl. So option C is correct. This question is question number 3. According to this question, which one of the following formula does not correctly represent bonding capacity of two atoms involved? Here phosphorus, option A, phosphorus valence electron 5, but due to presence of one positive charge here valence electron become 4. So phosphorus is tetravalent and complete their octet. This is correct. This is also correct. Oxygen complete their octet. Nitrogen also complete their octet. Hydrogen complete their duet. Here fluorine complete their octet because fluorine is monovalent, oxygen is divalent. But in this case, this carbon is pentavalent right now here, but actually carbon is maximum tetravalent. Okay, maximum tetravalent. So option D, according to this question, option D is correct. Now question number 4 is, it is based on ionic bond or electrovalent bond. According to this question, among the following, which compound will show higher lattice energy? First we will discuss about what is lattice energy. What is lattice energy? Lattice energy means amount of energy required to change or dissociate an ionic solid from their solid state to gaseous ions. It is called their lattice energy. Okay, and lattice energy in these compounds, higher lattice energy we can select. Actually radius of anion is same, fluorine, but radius of cation here in all elements are sodium, potassium, rubidium, cesium, fluoride. Here in top to bottom all are group first A members, and top to bottom here last cell 3s1, 4s1, 5s1 and 6s1. So top to bottom in same group atomic size increase. So maximum enthalpy shown by sodium fluoride, because atomic size of sodium is very less, size of fluorine is constant. So cations and anions are very strongly attract in sodium fluoride. So lattice enthalpy for sodium fluoride is very high. This is the correct answer, answer B. Question number 5. This question is based on bond parameters. According to this question, which of the following molecules is non-polar in nature? According to given options, whenever mu is equal to 0, then compound is non-polar. Whenever mu not equal to 0, then compound is polar. Okay. So in case of NO2, NO2 direction of dipole positive to negative, here direction of dipole is here mu not equal to 0, this is polar, this is polar compound or polar molecule. Now in case of POCl3, here mu not equal to 0 once again, because unsymmetrical distribution of atoms present around central atom phosphorus. Okay. Once again, in case of CH2O, delta double minus, delta plus, delta double minus and delta double plus. Direction of dipole positive to negative. So positive to negative and positive to negative. Now we can observe magnitude of this vector is upward side, and this is also due to same side, same direction of magnitude of dipole, we can add together. So mu not equal to 0. Okay. Now SbCl5, Sb is a member of nitrogen family. So nitrogen, phosphorus, arsenic, antimony, these are the member of group 15. Valence electron 5, and structure of SbCl5 is pentagonal bipyramidal. So here delta minus and delta minus partial charge, here delta 5 positive partial charge. So direction of dipole positive to negative, positive to negative, positive to negative, positive to negative, positive to negative and positive to negative. Now this vector is cancelled by this vector, and upper side vector is cancelled by lower side vector. Now mu is equal to 0. So option D is non-polar. Mu is 0, then non-polar. Non-polar, here this is polar, this is polar. Okay. Now question number 6 is calculation of dipole moment. According to this question, which of the following molecules has the maximum dipole moment? If mu is equal to 0, then molecule is non-polar, and mu not equal to 0, then molecule is polar. So in case of CO2 is non-polar, CO2 is non-polar, delta double minus, delta 4 positive, direction of dipole positive to negative. Now H is equal to number of hybrid orbitals sigma plus LP. From this formula, number of sigma bond, here pi these bonds are sigma bond, so sigma bond is 2 and lone pair is 0 at central atom, so H is equal to 2 means sp hybridization, and due to presence of sp hybridization and absence of lone pair electron at central atom, structure is linear and dipole is cancelled. Okay, bond angle is 180 degree. Now mu is equal to 0 and this is non-polar. Okay, now in case of CH4, delta plus, delta plus, delta plus and delta plus. Okay, here delta 4 negative, direction of dipole is positive to negative, positive to negative, positive to negative and positive to negative. Here due to this type of arrangement of dipole, here again dipole is cancelled, so here mu is equal to 0. Okay, again in case of NH3, NH3 N triple minus, here delta plus and delta plus, direction of dipole positive to negative, positive to negative and positive to negative. Okay, now mu not equal to 0 in case of NF3, here F is negative and negative, here positive, so dipole of direction of dipole positive to negative, mu again not equal to 0. Now how we can find maximum dipole in these 4 options? Here 0 and 0, but here condition is different. So on the basis of bond length between central atom and attached atoms, we can find maximum dipole. Here central atom is same, but bonded atoms are different. Central atom, last shell configuration nitrogen 2s2 2p3, but whenever bonded with hydrogen last shell configuration 1s1, but fluorine last shell configuration 2s2 2p5. So bond length is greater in case of N and F, is greater than bond length of N and H. So dipole moment is inversely proportional to 1 by bond length. So maximum dipole present in NH3. Okay, this question is question number 7. This question is based on order of arrangement of dipole moment in these molecules. According to this question, which of the following correct order of dipole moment in these molecules? In case of boron trifluoride, we can observe dipole moment delta minus and delta P positive. Direction of dipole positive to negative and positive to negative. Now resultant of two dipole is downward direction due to calcination of these two dipoles. Mu is equal to 0, so this molecule comes under non-polar molecule. Okay, after that we will discuss about 3 another molecules given in question, which is NH3, NF3 and H2O. Okay, now here delta plus, here delta plus, here delta plus, here delta 3 minus, here charge is delta minus, here delta 3 plus, here delta plus and delta double minus. So direction is dipole is positive to negative, 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 positive to negative. Now direction of dipole is in this direction. Here direction of dipole in this direction. Here direction of dipole is in this direction. So mu not equal to 0, mu not equal to 0, mu not equal to 0, all are non-polar. Now for the arrangement of correct order of dipole moment in these molecules, we can find with the help of bond length. Suppose central atom, last cell configuration of central atom for nitrogen 2s2, 2s2, 2p3, for hydrogen 1s1, for fluorine 2s2, 2p5. So bond length of O and H is very less than NH and NF. So we can arrange according to concept, because bond length inversely proportional to dipole moment. Okay, a small bond length, higher dipole moment. So in H2O maximum value of dipole, then NS3, then NF3, then boron trifluoride. Okay, this is correct order of dipole moment in these given molecules. So option B is correct. Okay, this question is question number 8. This question is based on calculation of bond angle and hybridization. According to question number 8, the species having bond angle is 120 degree. According to question and given options, we can draw a structure of ClF3 initially. ClF3. This is the structure of ClF3. This is lone pair electron. Okay, this is lone pair electron, and here bond angle is 175 degree. Hybridization is sigma plus LP. Sigma is 3, LP is 2, 5 is equal to 5. So hybridization sp3d hybridization is here. Now in case of NCl3, here bond angle is 107.3 degree and hybridization is sigma plus LP. So 3 plus 1 is equal to 4. sp3 hybridization is here in NCl3. In case of BCl3, H is equal to sigma plus LP. Sigma is 3, LP is 0, is equal to 3. It means sp2 hybridization here, bond angle is 120 degree, and option C is correct according to given option. But now in case of phosphine pH3, we can also find hybridization and bond angle. H is equal to sigma plus LP. 3 plus 1 is equal to 4. So sp3 hybridization is here, and bond angle is 93.5 degree. According to given options, option C is correct. This question is based on order of arrangement of bond length. According to this question, the correct order of increasing bond length of C single bond H, C single bond O, C single bond C and C double bond C. According to basic concept, bond length inversely proportional to 1 by bond order. So here bond order is 3, bond order is 2 and bond order is 1. So bond length increase, bond length increase in left to right way. Now according to this concept, we can arrange bond length. So bond length of C single bond C is very large. After that we can arrange CO, because here configuration 2s2 2p2 and 2s2 2p4. okay, so bond length is large. Then we can arrange CO. okay, after that next third is C double bond C and last is again C single bond H. This is correct arrangement of increasing order of bond length in these components. So according to given datas, we can find answer number A is correct. Now question number 10 is based on calculation of formal charge. According to this question, which of the following structure is the most preferred and hence lowest energy for SO3? Now in these options we can observe formal charge of oxygen is 0, 0 and 0. okay, these options are incorrect. Here d pi p pi involving d pi p pi involvement is present and formal charge of oxygen atom is 0. Every oxygen atom, for calculation of formal charge of O atom in SO3 is equal to total valence electron of oxygen minus total non-bonded electrons of oxygen minus half into total bonded electrons. So total valence electron of oxygen is 6 minus total non-bonding electron 1 2 3 4 minus half into total bonding electron 1 2 3 4. okay, so 2 2 ja 4. Now 6 minus 4 minus 2, 6 minus 6 is equal to 0. Here formal charge is 0 for this oxygen and this oxygen. So due to 0 formal charge and d pi p pi overlapping, okay, d pi p pi involvement, here lowest energy for SO3, option D is correct. Now question number 11 is based on calculation of order of bond angle. According to this question, the correct order of increasing bond angles in the following triatomic species is these options. In these options we can calculate correct answer. In case of NO2, okay, NO2 single positive, here the structure of NO2 is linear and bond angle is 180 degree. After that, in case of NO2, This is the structure of NO2 single positive. Now, in case of NO2, we can draw the structure of NO2. This is a lone pair. Here, bond angle is 134 degree. After that, NO2 single negative. Okay. Then, the structure of NO2 single negative is due to presence of single negative charge here. Okay. Now the angle is become decreased due to increasement of lone pair. From whisper theory, repulsion LP maximum. After that LP BP repulsion and minimum repulsion BP and BP. Okay. So due to increasement of electrons at central atom, bond angle become decrease. So now bond angle is 115 degree. So order of arrangement of according to bond angle in these species, we can write here maximum bond angle is 180 degree. Okay, 180 degree. So bond angle NO2 positive maximum. After that NO2. Okay, and after that NO2 minus. Okay, this is the correct answer. Now according to these options, option D is correct. Now question number 12 is based on order of bond length. Bond length is inversely proportional to 1 by bond order. Okay, so in case of CO, bond order is 3. In case of CO2, bond order we can calculate by formula total number of bonds by total number of sigma bonds. So total number of bond 1 2 3 4. Total number of sigma bond 1 2, because pi sigma is 2. So 2 is bond order. 2 is bond order of CO2. After that, in case of CO3, carbonate ion. Okay. Now bond order is equal to, the formula is bond order is equal to, this is the structure of CO3 double minus carbonate ion. Bond order is equal to number of sigma bond, total number of bonds 4 divided by sigma bond, pi sigma divided by 3. So 1.33 is bond order. Now 1.33 is bond order. Now from formula here, bond length inversely proportional to bond order. So now we can write order of bond length. So maximum bond order, minimum bond length. So carbonate ion, maximum bond length. After that CO2. After that CO. This is the order, increasing order of bond length. Now according to given option, option C is correct. Question number 13 is based on Fazan rules. According to this question, the correct sequence of increasing covalent character is represented by these 4 options. Now from Fazan's rules, a small cation and large anion having more covalent properties. Okay, so a small cation, large anion. Now from given options, size of cation is lithium, beryllium and sodium. Last cell configuration 2s1, 2s2 and 3s1. Okay, so according to given metals size, lithium and beryllium left to right size decrease. So atomic size of beryllium is less than lithium and lithium is less than sodium. So a small cation, large anion. Okay, after that we can find easily on the basis of these formulas correct answer of representation of covalent character. So beryllium more covalent than lithium, more covalent than sodium. So their compound is BeCl2. Okay, BeCl2 is more covalent. So we can write here BeCl2 is more covalent than lithium chloride, is more covalent than sodium chloride. Okay, from Fazan group. So according to given options, option C is correct. Question number 14 is based on calculation of permanent dipole. Now, according to question, which of the following would have a permanent dipole moment? Option first, silicon tetrafluoride. The structure of silicon tetrafluoride is tetrahedral. Okay, so delta minus, delta minus, delta minus and delta minus, delta 4 plus. Okay, dipole, direction of dipole is positive to negative, positive to negative, positive to negative and positive to negative. So here resultant in this direction, so dipole is cancelled, mu is equal to 0, no dipole is here. Now in case of SF4, in case of SF4, okay, delta minus, 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 minus and delta 4 plus. Now positive to negative, positive to negative, positive to negative, positive to negative. Now this dipole cancel, but direction of dipole is this side and this side. Now resultant is this side. Now mu is not equal to 0, so permanent dipole is present here. So option B is correct. Now after that we can check xenon tetrafluoride. Okay, chlorine, fluorine, chlorine and fluorine. Okay, delta minus, minus, minus and delta minus, delta 4 positive, fraction of dipole positive to negative, positive to negative, positive to negative, positive to negative. So here resultant is cancelled. Okay, resultant of dipole is cancelled, so mu is equal to once again 0. Now in case of boron trifluoride, boron trifluoride, delta minus, delta minus, delta minus and delta 3 positive, positive to negative dipole direction, positive to negative and positive to negative. So this dipole is cancelled by this dipole, so mu is equal to 0. So only permanent dipole is present in SF4. You can take a screenshot. Question number 15 is completely based on calculation of permanent dipole. According to this question, which of the following molecules does not process permanent dipole moment? In case of CH2, the structure is linear, so here this is completely non-polar. Okay, so no dipole, mu is equal to 0. Okay, now here in case of SO3, SO3 is trigonal planar due to sp2 hybridization. Okay, this is as here sp hybridization is present, the structure is linear, bond angle is 180 degree. Okay, here this is also non-polar, this is also non-polar. Okay, so both options are correct. In SO3 and CH2, no permanent dipole is present, but here according to Lewis-Dot structure, 3 resonating structures we can observe in case of SO3. So whenever which one is correct question, then option E is correct. For multi option you can tick A and D, both are correct. Now in case of H2S, in case of H2S, hydrogen sulfide, okay, H is equal to sigma plus Lp, sigma is equal to 2 plus Lp 2, means 4, means sp 3 hybridization. Okay, due to presence of lone pair at center atom, this is polar. Okay, and SO2, you can draw this structure in excited state, otherwise Lewis-Dot structure. Okay, this is the structure of SO2. Otherwise, from Lewis-Dot structure you can draw this structure, and due to resonance effect, due to resonating structure of sulfur, you can observe delocalization of pi bond and one delocalized structure. Okay, so finally in this question answer is correct.